Okay, we're picking up on the review for sections 2.1 to 2.3 and 2.7 in Algebra 2. And this is similar to problem 29 on your review. All right, we are going to, first of all, find the positive and negative intervals here. And I'm going to start with this negative interval here. It's a negative interval because everywhere you are, every point along there, the y value is negative, in other words, down. So we're going to fill in that interval here. It starts on the left with an x value of -1 and goes until you get to an x value of 3. So here's the interval that's negative. Then there's two positive intervals. I'll highlight this one here, and then the other one's going to be over there. So let's do this one on the left first. Now, the x value on the left of that thing, since it goes forever to the left, is -infinity. You finally get over to the right side of that thing and it hits at -1. So that's the right side of that interval. Then you pick up on this section and it goes forever to the right, starting at 3. In other words, go left to right when you do that. Okay, the next picture over here has this section here starting at x equals -2.5 and ending at +4.5. And the y values are all up there or positive. So that's a positive interval from -2.5 to 4.5. Then you have a negative interval right here and another one right here. Those are places where the y values go downwards, and consequently you have negative intervals because y's are negative when you go down. But then you have to realize they're looking for the x values, the starting and ending x values in those locations. So we have one section that starts forever to the left and goes until it gets to -2.5. And then on the other side, it starts at 4.5 and goes forever to the right. I think I put the wrong number there. Hang on, let me fix it. Starts at 4.5 and goes forever to the right. Okay, this is the same problem we just did, except that we have to come up with our own picture. Now I'm going to point out right away that this is an upside down parabola, and we're going to try and find the zeros. So put a 0 for the y. Let's factor out a -2. You can distribute if you want to check that. And then we'll put some stardust on this thing. We want a 2 on the wings. And 2 times -4 is -8. So we got to get them to multiply to -8 and add to give -7. And I think 1 and -8 will work. Those numbers do add up to -7 and they multiply to give -8. So now this side becomes 1 over -4. So now we're down to -2 times 2x plus 1 and 1x minus 4. It's a waste of time setting this part equal to 0. But this one, if you do the work, when you set it equal to 0, you get x equals -1/2. And this side gives x equals 4. So you're going to draw a sketch of an upside down parabola that has these zeros, -1/2, comma 0, and 4, 0. And you can see this middle section is a positive interval. So it starts at -1/2 for x and ends when x is 4. And this little section down here, let me highlight it, is negative since the y values go down there. And this section over here, this section over here also has negative y values. So on the left, from negative infinity until you get to negative 1/2, the y values are all negative there. And then from 4 forever to the right, you also have negative y values there. Okay, this next one here, we're going to start by putting a 0 for the y, factoring out the 3, and then factor it one more time. This is a difference of squares problem, so with a minus sign between perfect squares, you can take the shortcut. X times x to get the x squared, 4 times 4 to get to 16. You have to make one positive and one negative to get your negative 16. And this yields setting 3 equal to 0 is a waste of time. Doesn't work. If you set that equal to 0, you get negative 4. And setting this equal to 0, you get positive 4. Now we have an a value that's positive, so this is a right side up parabola. And the two locations of those zeros are negative 4, 0 here, and positive 4, 0 over there. So we're going to start with the middle section, and since the y values are all down in that section, you're going to call that the negative interval. So from negative 4 to 4 is a negative interval. And then over here you have a positive interval that goes from forever to the left to negative 4. And then you pick up on the other side starting at 4 and going forever to the right. And those are your positive and negative intervals for that problem. So on the next video, I'll show you how to graph a parabola and a line and come up with the solutions to a system using those two shapes.